Okay, step one is where the acid protonates the oxygen on the alcohol. So CH3, CH2, CH2, CH2OH. I am going to draw the two lone pairs on that oxygen on the alcohol plus H3PO4. Phosphoric is an acid. It's a weak acid, but it's an acid nonetheless. So the O, one of the lone pairs on the O grabs an H off of H3PO4. And now you have CH3, CH2, CH2, CH2O with two H's. And you have a lone pair still. And you have a positive charge on the oxygen. And the H3PO4 becomes H2PO4 negative. Next, step two. So the products in step one are the reactants in step two. CH3, CH2, and then I will spell out the H's on the carbon right next to the carbon that bears the oxygen. O, H, H. Okay, so oxygen is positively charged, and oxygen is the second most electronegative element. It is very unhappy. So what happens is the H2PO4 that was produced in the first step, even though it's not very basic, it's basic enough to remove an H off of that beta carbon, the carbon that is right next to the carbon that bears the oxygen. Yeah, so the H2PO4 grabs the H, and what happens is that their bond goes between those two carbons, and what happens is that bond goes to the oxygen as a second lone pair, and H2O leaves the molecule. CH3, CH2, and then CH, the second H is gone, CH, H. And in the process, you produce H2O. That is why it's called condensation or dehydration. You remove water from the structure. And H3PO4 is regenerated. So in step one, H3PO4 was used up, but at the very end, H3PO4 was recovered, and so we say that H3PO4 is a catalyst.